Are we live? Hello, everyone, and welcome to the Geo AI podcast. Welcome to today's episode where we're talking about, yes, fake news. Not really fake news. We're talking about something else that's a little bit different than reality. It's called synthetic data. This is data. It looks and feels like a real data source that you might have purchased from the AWS marketplace or captured from a census file or something, but it's not real. It is made to look specifically like what real data looks like, same distributions and those details, but this is not actually representative of anything that may happen in the real world. So what does that actually mean? What is synthetic about it? We're going to talk about that topic today and talk about many of the use cases for synthetic data. And in this process, I will be joined by Antonio Correas, a co-founder and chief product officer for Skymantics. Antonio, welcome to the GeoAI podcast. Welcome back, I should say, as you were on one of our previous episodes. How are you?
I'm good. Thank you so much, Ajay, for the opportunity and for having me. It's really fun to be here at the podcast.
And I'm looking forward to the topic of synthetic data. So let me tell you when I first heard about this, and I definitely want to hear about where you first heard about synthetic data and what got you into it. I remember I was in a conference meeting someone for the first time, and we did the same song and dance we all do, how are you? What's your name? What's your name? Where do you work? What do you do? And all that. And he said they work on synthetic data. It was the first time I heard about it, so I did not know what that was. And I said, what is that? Well, they say they make data to replicate a real scenario or situation that their client may experience so they can do pilot testing or product testing based on this synthetic data. I was like, oh, so you just pretend that you've got data that you can use for modeling and simulation? And I don't know exactly how the rest of the conversation went, but it was clear that there is an element of simulation, of not like make-believe in the sense of a child's fairy tale, but this is not data that is relevant to a real-world scenario, but we can have a lot of it, and we can use it to train models that act on real-world scenarios. So that's sort of been my understanding of synthetic data since then. And now, of course, that market has expanded, and there's many organizations, many companies with some mature product offerings in the area. But we certainly want to hear about your first impressions of synthetic data and where you see the industry now, where you see the topic of synthetic data today.
Absolutely, yes, exactly. So it's been also a journey for us, not only for me but for everyone in the team at Skymantics. So our background, so we are a team of technologists, right? And our background has always been AI, geospatial intelligence, and data science. So we have always been very focused on the data. And every time that we had a customer coming to us to solve a problem or to develop a new system for them, we always needed data that would train the models that we would develop for them, and then also have data for testing the software at the end, right? So data is really essential. And then one day we had a customer that had a very particular problem, which was that they needed to model AI algorithms for a specific application, but the data that they have, and they do have data, they cannot use it. And I said, how is that? It's because it's sensitive data. It is data that has names and social security numbers from the customers. So we cannot tap into that data. And we're like, okay, how do we solve that problem? Can we take that data and anonymize it and then still use it for training? I say, no, that data is forbidden. We just cannot use it. So you need to create a mirror of our data using other data sources that are open, so on, and just replicate the data set so that we can use it as well as good as if it was our production data. So you see, and that's really the entry point, the main use case for the synthetic data, is that when you have real data sets, even if they are anonymized, it's not enough for you. You just need to create completely new data sets that are impossible to trace back to your real data, so that you cannot re-identify individuals. You see,
Yeah.
and this is a problem that is becoming even more and more important, because sometimes you have data and you can use it, but your data is not enough, meaning it's not large enough, or it's not complete enough, or it is biased. And that's because AI needs vast amounts of data to be properly trained and tested, and the newer Gen AI algorithms even more. So
Right.
the data from the real world is becoming not enough. The data that is gathered from surveys or measurements is just not enough, you see.
Right. So you need to fill it in with data that you replicate. So it's true that when you're filling in with the data, that the synthetic data matches some characteristics of the underlying actual data, right? The distribution, the range of high and low values, if you will, that those things are the same. The frequency of a particular value appearing in the data set may be the same.
Exactly.
In that case, how do you address the issue of potential bias in the quote real data that you're now using to synthesize? How do you address that?
Correct. Yeah. So you need to take into account first to recognize that the data sources that you have for the models that you think you want to develop, they may be biased, right? So the first thing that you need to understand is, what is the bias that you want to fix, and based on what? And so that usually translates into what are the edge cases or the corner cases that are not in the data that you know, but you know that they should be in your model. Okay, so then what we, for instance, do is we bring our army of data scientists. They will look at the data sources that you have, at least at the data schema. We look at what are the possible outcomes or the corner cases that you want to make sure that are present in the data that you want to generate. And we will make sure that we parameterize a system that will make sure that there is a certain amount of occurrence of those edge cases that will balance the bias that you're looking to destroy. So it's really a matter of what scenarios you want to have.
Right. Interesting. It almost sounds like, and I know when we say the word bias, we mean a negative connotation, right? We mean things we don't want, right? But it almost sounds like you could create synthetic data to have, let's say you're taking one data set that it's incomplete or it's not enough to train a model, whatever, anything like that. Now you want to use synthetic data to make it large enough to train a model to do a particular function.
Yeah.
And if you're doing that, you could take, I wonder if different parameters to have multiple versions, different versions of now a synthesized data set to train the model under broadly different criteria.
Correct.
So in effect, we could say, all right, we want to get rid of bias, but let's see what the model output would look like under bias A, bias B, bias C, bias D, whatever, and then see how that might affect the work of a model, right? The output of a model.
Correct. Exactly. Yeah. And in the end, it's just as you said, it really comes down to what is the function, what is the purpose of your model, right? And there is always a human factor involved, where the humans that are going to use the end users of these applications, they need to know very well what they want. AI is not going to solve the problem for you if you don't know what your problem is. So if your problem is that you want that you currently have a model, let's say, that recognizes faces, but you know that in your training data for training that model, you are missing specific kinds of face traits, then you need to solve that. And that's a bias that you need to solve, even if
you need to add that bias in somehow so that the model works for anyone, any face.
Exactly.
Right.
And a good example to that we encountered very recently is to have very rare scenarios, right? That you have never encountered, or they are very rarely found, but you know that they can happen. And since the impact of those scenarios is very serious, you want to make sure that your AI models take them into account. So for instance, we are working also in the aviation sector, and let's say that you want to model the national airspace and to see how it behaves when you have, like, let's say, a perfect storm of factors. Like, for instance, you have a northern blizzard, and then at the same time you have a major IT problem with the operators. We know that both problems have happened in the past, but not at the same time. So, but we know that that could eventually happen. So we need to be able to recreate all the flights that we are currently doing with synthesizing flight plans. We would need to know what happens with all the ground delays and the reroutes when both of these events happen at the same time. It's a very rare scenario that you don't have, but we need to include it.
So in effect, you could create scenarios or create data that depicts scenarios that have not in fact happened, but this way you allow it to prepare for it.
Exactly.
So should they happen, I mean, so these are sort of scenarios as you're depicting them that it's plausible, but rare.
It's plausible.
Very rare, maybe, but it's plausible that happens, so you may as well prepare for it. Right. And maybe as a follow-on question, Paul, we'll ask you about, hey, if you're modeling U.S. airspace, are you modeling aliens in the airspace as well at any time? Just kidding. Just kidding. That's a totally different podcast. There's plenty of those podcasts.
Yeah. X-Files.
But yes. So Skymantics is doing the creation of synthetic data. Tell us about the process. Tell us about how you do it. What's the secret sauce of creating synthetic data?
Right. So we are packaging on all our technology in a project that we call Data Genesis. Okay. That to us, it's the next generation technology for synthetic data. And when I say that, it means that there was a first generation, and then we want to go beyond, right? So the initial generation of synthetic data is created by so most of the providers that you will find on the internet, they will give you that. So they can read any data schema, right? And then they will apply usually Gen AI algorithms like variable autoencoders or adversarial networks to recreate a replica of the source data set, okay, respecting the statistical distributions. That is nice. That is easy to use, and it will solve the problem of the data scarcity. Like let's say, for instance, that you have a source data set of 10,000 data points, and you need 1 million. So that could solve you that problem.
Scarcity.
The problem with that, problem with that is that when you are asking this technology to do that, it's like asking a painter to paint a portrait of something. So it will do it, but then if you are asking that artist to make the same portrait with some tweaks, it will not be able to do that. It will start from scratch, and it will do something completely different, and you will never know what's behind that. It's like a black box that you will never understand because of the nature of these Gen AI algorithms that are used for that. So what we are doing is that we are using a collection of micro AI models that go step by step to variable selection, dimensionality reduction. We use unsupervised machine learning for clustering. Then we use machine learning for classification. And then we create a collection of really small micro AI models that work together to understand first the parameters of your source data, to translate that into coefficients that you can control and tweak up and down. And then you have a system that is modeled like a machine that you can control. And then based on that, we create what we call a synthetic digital twin that models a reality that you can play with. It's like a sandbox. So it's not just a box that will spit out synthetic data that looks like the original one that you fed, that you feed, but it's like a whole system that you can that you can play with. Like, for instance, let's say that you have a population of the state of Atlanta that you want to generate. So with our system, you can read what the population looks like now, and then it will create a system of coefficients that then you can tweak so that you can create a future version of the Atlanta state with changes like you can incorporate demographic changes or a scenario of recession, or you can take as a specific neighborhood, and you can extrapolate it to a different place, or you can scale it up or scale it down. You see, so you have a collection of parameters of your system that you can create alternative realities based on that. A little bit like a Sims game.
Like what if analysis, yes.
Yeah.
So you mentioned a couple of use cases. We have a couple of use cases also from the health domain that we'd love to discuss, right? So one of the things that we do, and you've been a part of this too, you've seen it, is develop our heat health risk index, right? As we know that there are plenty of places in the world where the average daily temperature, especially in the summer months, of course, is rising, and some places rising fairly aggressively. And that has led to an increase in number of people who need even hospitalization for heat, stroke, heat exhaustion, and even other healthcare conditions that are exacerbated by that exposure to extreme heat. And so one thing that we've seen as we work with municipalities is that sometimes learning about heat days before or even a month before is sometimes a little too late for them to plan the necessary resources that they would like to deploy to that problem. So what we thought of is, let's synthesize the data for the following years. We already have long-term projections of temperature models and environmental models and climate models for years out, right? They exist. You can take many of them. There's a variety, and you could even run analysis on sort of aggregating multiple climate models in the future. And then if we can take census and population demographic data for a particular area, you mentioned Atlanta, a well-known hot city, but New York City, county environments, any place, globally even, then we should be able to project a heat health risk index for future years. Now, of course, this is synthetic data, and even the climate models are projections. They're not exact, but they're probably, this is sort of the broad question on synthetic data and digital twins of synthetic data. If we could model next year's heat this year, that should be good enough for resource allocation and for long-term planning, correct?
Correct. Yeah. I mean, for those resources that require one year time, yes, but there may be other resources like building hospital, building cooling centers, or building roads to get to those places that may take longer. So it will be very legitimate to also want to have a 5 or 10 years out forecast. Right?
Exactly. I mean, where we came with the 3 years is in healthcare, there is a report that nonprofit hospitals have to produce on a 3-year cycle. It's called the Community Health Needs Assessment. Right. So nonprofit hospitals, as it's an IRS requirement as being part of a nonprofit or having nonprofit designation, they have to be aware of the health needs of the community they serve, called their catchment area. So they have to do a report, share the report with the IRS on a 3-year cycle. So we're essentially saying that we can model the social factors impacting health outcomes in the catchment area today and for a 3-year period. So we can produce that for them in an instantaneous manner. I mean, obviously it's synthetic data, so it's not the exact, but it does allow for long-term projections and plannings, which is the purpose of this report. The hospital has now a report that they can use for their planning, not just for the immediate time frame, but for the 3-year time frame of the entire model. Clearly, in other domains, different timelines are there. For healthcare, the IRS Community Health Needs Assessment (CHNA) model for 3 years has some value.
Yeah, correct. Yeah, exactly.
Hey,
Sorry.
Paul.
Another thing on this topic is that another thing to consider when it comes to utilizing population data, especially from stuff like the US Census Bureau or even places like the CDC, is oftentimes that data is 2 or 3 years behind the current year because of how they're doing the calculations of the estimates for the populations. And so we've kind of gone over the kind of planning sort of use case of looking into the future, but it synthetic population data also has implications for the day-to-day operations of, say, disaster response when it comes to heat, especially, or in, say, just to have the current day populations instead of working with populations data that's 1 or 2 years old, and also expands into real time events, like looking into stuff, say, like evacuation planning. How do you model the number of people that are actually evacuated versus decide to shelter in place, or have other mechanisms when dealing with other disasters, whether it be fires or hurricanes or flooding. So there's a lot of use cases for synthetic data.
Exactly. Yeah, and I think you just touched a very important point, Paul, um, which is that with synthetic data, you can create, so you can make discrete event simulations, like make people. It's like the Sims game that I mentioned.
Right.
You not only have aggregate statistics of age or socioeconomic status, or house type that you can correlate with the surface temperature, right? You have an actual living population that you can play with. It's like a video game. So if there is a disaster that hits like heat wave, you can make them have to go to the nearest cooling center within their mobility restrictions, incorporating the behavior that they will exhibit when this type of disaster shows, and also considering the vulnerability that they have, which is inherent to their demographic segment, their health risk,
Hmm.
the type of building that they live in. So you can simulate what will happen, and you can get much richer results on the outcomes of that event based on just one variable aggregate statistic, which doesn't really give you enough information to make decisions.
Right. And so what you're describing, this sort of long-term future planning, what if analysis, right? Sort of, this is essentially the purpose of a digital twin, right? It's to use to, I mean, I hate to use the words, but the words that come to mind are that you play with the digital twin to learn about the real life system. And then you manage the real life system based on what you learn by manipulating variables and data in the digital twin.
Yeah.
That's what we're talking about with the use of synthetic data and simulation and modeling with the AI models that we build off of that data.
Right. Yeah. The difference between a classical, let's say, the traditional type of digital twin and the synthetic digital twin is that the traditional digital twin has been built with parametric formulas that describe the behavior of the system, and then you just have a system that you know exactly how it behaves. But the difference here is that we are feeding that system with synthetic data, so it can learn from new scenarios based on new data, so it can create a new version of itself in a slightly different or a completely different environment. And let's see how different
Right.
that digital twin will be in that different scenario.
Yeah, that's very interesting, right? Now we have new data. And not only is the data new, but the parameters of the system are new. So in that case, how do you validate the precision and utility of the synthetic data that you're using?
Yeah, so validation is really important, specifically to make sure that your data is not fake, that it's just synthetic, but it's still real, right? So you need to build validation pipelines. You need a checkpoint at the end of the generation, and what we do, for instance, is that at the end of every step of the generation, at every micro model, there will be validation checkpoint to make sure that the data generated so far is good. And there are several ways that you can do that. We use all of them. One is to have statistical comparisons with your source data, so that you make sure that the statistical distributions make sense, and also that the multivariate correlations make sense. So because there are attributes that have strong correlations between them, you have to make sure that those correlations are kept through the generation. Then you can have rule engines to make sure that you create boundaries of maximum and minimum values that you don't want to go beyond. And then something that is unavoidable is to have a human in the loop. So we make a lot of use of subject matter expertise. So we have people who are experts in socioeconomics, in aviation, in healthcare, when you work with you guys, and nothing can replace the experience and the intuition of someone who has been working for years in an industry and say, hey, this data looks sketchy. This is not right. Let's see what's wrong in the generation algorithm. And that's something that keeping a human in critical checkpoints is, I think, it's an essential part of the validation, and to make sure that the data remains accurate, but it's also easier enough to generate.
Yeah, that's excellent. And we don't want to forget that while we're doing all this, we're also addressing some of the core problems we have with the big data that we do have. Bias, for one, is a big problem. And there's been many, if you just do even a cursory search, there's many times when health AI models that are used in the real world demonstrate a strong bias that causes harm, that causes actual harm in the delivery of patient care. Whether it's insurers who advocate for the wrong patients based on past history of spend across patient lines. So have you seen examples of how the use of synthetic data actually can help lessen the impact, if not remove these biases?
Yes. So in the healthcare sector, let me think about it. So we know we have been working on synthetic populations for the tax sector, to train tax fraud algorithms, and we know, for instance, that there is a lot of introduced bias in very specific corner cases. For instance, for claiming child credits that are just not considered in the tax fraud detection system because they are just so rare that no one spends any time in considering them. So by just making sure that those edge cases are also there in the data set that will train the algorithms, we'll know that then they can flag automatically those cases so that they can be inspected.
Yeah, excellent. That's excellent. And those are great use cases. We've talked about aviation, about aging the population for future community health needs assessments, for heat. There's taxes. There's a lot of use cases for synthetic data, both when the existing data is available but sensitive, when the existing data is not available, or even when we need to use future data that, of course, doesn't exist. Is there an almost no limit to what synthetic data can do?
I'm wondering the same, right? Like right now, we discovered a new whole market that we can tap into with synthetic data, which is business intelligence. So we are looking right now into how to take. So this is specific for our synthetic population, right? So we are looking into how to combine all the attributes that we can synthesize on demographics, socioeconomics, health, and incorporate psychographic attributes which define the behavior of the population of specific types of profile to generate things like consumer demand models. So I can see a very straightforward use case. For instance, you are a company who wants to open shop in a particular area, but you don't know exactly what would be the best location to open, so that you are closer to the consumers that will be interested in your products, and then you can also have access to the workforce with the right skills. So by incorporating this, then you can create the actual much richer population profiles with also the behavioral dimension, so that you know how they behave now and then how they would behave in a few years if some of the basic demographic attributes change. So there is really like a lot of use cases, and this is just
Right.
the beginning. They're going to be popping up more and more.
You know, this interesting. We keep talking about the what if analysis, and you say you can edit or tweak some of the variables. In that case, this synthetic data is not necessarily matching the distributions of the real data that it's based on, correct?
Correct. I mean, yeah, if you are creating an alternative scenario or a future scenario, then it is based on the same parameters, but you are tweaking the parameters to create an alternative reality. So yeah, that is true.
That must then complicate efforts at validation.
It does, but then, so what we do then, yeah, is that you need to validate that the parameters or the coefficients of your model that is based on the real data are accurate. Now, it's true that it is, since no one has a crystal ball, it's impossible to validate a reality that doesn't exist, right?
Mm-hmm.
So it's just about, it's a scenario forecasting exercise. You're looking at best cases, worst cases, and then that will educate your decisions in the future. But the validation beyond the current point where you are based on the current reality that you know is just by definition not possible. You can only validate the parameters up to that point.
Right, because in terms of aging the population, right, when we want to understand something about next year's heat health risk index, obviously the level of population itself is a contributing factor. The density of the population, where do people live, is a factor. And as we know, the cool part of town changes over time, and somehow there may be a shift that these zip codes, these census tracts have more people moving into them, and those have people moving out of them, right? For instance, right now in the country, we know that there is a general movement from California to Texas and Florida. However, the movement to Florida, because of their insurance rates and their insurance model for real estate there is challenging. There's that in-migration is slowed lately. So all of these factors would need to be in place when you're aging the population in those particular areas. And that allows you to play with that and say, look, we're going to propose widely different characteristics for the population in the next year and see how that impacts heat or social factors, in case of the community health needs assessment, what that's going to look like in the incoming years.
Exactly. Yeah. But again, as long as the parameters of your model are valid, you have a certain level of confidence that future or that alternative scenario that you're looking at is accurate. Yeah.
Or if not accurate, that may be, like you said, you can't validate the future. If not accurate, it is sufficient for planning, right?
Yeah.
We can use that for planning because we're going to plan for the future. But of course, every day between today and next year, between today and 2 years out, we're going to know today's data every day. And so as it changes, we can adapt our plans, but we'll have plans in place that are informed by new sets of data.
Absolutely. Yes, exactly. You say it right. Yep. Exactly.
Well, this is really exciting. I mean, this completely changes the challenge in data acquisition and data curation. Right? We can now curate what, in some cases, cost a lot of money to acquire.
Yep.
We can now synthesize, in some cases what costs a lot of money to acquire.
Yep.
That's an exciting part of the future. It's a synthetic digital twin for tomorrow's data.
Exactly. Yeah. I think, there is a lot of potential here. I think the foundational models are getting there. So now there is going to be a lot of synthetic data that can be generated in large quantities, the quality can be controlled and can be validated, so that when you have to model very complex things like AI agents that make decisions based on an environment, then you are sure that those decisions, that those models that drive those decisions, they're based on synthetic data that can represent the potential reality that the agent needs to make the decision based on. And then also that data that you are using for training those agents is safe to use. I think those are the main two things that are going to be driving the adoption of synthetic data.
Wow. Well, thank you for joining us, Antonio, and talking about synthetic data and the drivers of what causes it and what's leading to the adoption of synthetic data. Tell us, how can the audience keep in touch with you or reach out to you?
Well, there are many ways. You can just visit our website, schematics.com. We have ways to contact us. And you can also drop me an email at antonio.correas at schematics.com. And yeah, I'll be very happy to exchange any ideas. And if you're around in the area of Melbourne, Florida, or Washington, D.C., very happy to have a coffee also.
Nice. Yes, Melbourne, Florida, or Washington, D.C.
Yeah.
Yeah.
Well,
I hope there will be a number of listeners that will take you up on that, because yes, we do not have enough in-person interaction in the world, really since COVID. It's coming back, but we could still do more.
Yeah.
We still do more. Well, thank you for joining us. Thank you again. Thanks, Paul, for being here as always. And this is another, I think, fun episode of the GeoAI podcast. We'll be back in 2 weeks with another episode on another topic on information technology and AI in general. We'll talk to everyone then. Until then, have a great